In this tutorial, I will show you how to create a smart switch using Blynk and ESP IoT development board that can be controlled remotely from anywhere in the world. Blynk is a user-friendly platform that enables the creation of custom IoT applications for your own projects. And ESP IoT development boards are powerful microcontrollers commonly used in IoT devices. By the end of this video, you will have a better understanding of how Blynk works and how to integrate it with ESP32 to create a smart switch. I will cover all the necessary steps, including creating a dashboard, configuring ESP32 with Arduino IDE, and setting up Blynk app. Stay tuned. What is needed? An ESP32 development board, a breadboard, 4 low relay modules, a keypad with 4 buttons, some jumpers, and Arduino IDE installed on your operating system. To start, navigate to blynk.cloud webpage. If you do not have a Blynk account, click Create New Account. If you have one, enter its credentials. Log into your account. On the left menu, navigate to Templates. Select New Template. Set a name for it. Choose your hardware. Mine is ESP32. And connection type is Wi-Fi, as I want to connect my ESP32 to network via Wi-Fi. You can add a description to your template. Click Done. Then navigate to Data Streams tab. Click New Data Stream. Select Virtual Pin. Set a name for your data stream. I set its name to switch 1. Specify a color. Associate virtual pin 0 to switch 1. Data type is integer. Unit is none. Minimum is 0. Maximum is 1. In advanced settings, I enable sync with latest server value every time device connects to the cloud. Then click Create. My project has 4 relays, so I need 4 data streams. I copy switch 1, change its name to switch 2, associate virtual pin number 1 to this data stream. Create. I do it again. This time I set its name to switch 3. Automatically, virtual pin 2 is selected. Create. This time I set its name to switch 4. Create. I need 2 more data streams. One to turn on all relays, or let's say trigger all relays. Set its name to all 1. Associate virtual pin 4 to this data stream and create. The next one will be all off. Change its color to black, for instance. Create. After creating data streams, navigate to Web Dashboard. Drag switch and paste it here. Open its settings. Set a name for it, switch 1. Select the data stream for it, switch 1. Save. Make a copy of it. Open its setting. Set its name to switch 2. Data stream switch 2. Save. I need 4 switches. change the name of this one to switch 3. Select data stream switch 3. Save. And the last one. Set its name to switch 4. Data stream switch 4. Save. I need 2 other switches for all on and all off. Set this name to all on. Select all on data stream for it. Save. And the last one, I change its name to all off. Choose all off data stream for it. And the color black. Save. That's it. I click Save. Now navigate to Search section. Select New Device. Choose from template. Choose the template, a smart switch template. Set a name for your device, a smart switch, for example. Create. Copy these lines. We need them while configuring our ESP32 with Arduino IDE. If you lost these lines, you can find them by navigating to the list of devices, opening the device by clicking on it. Navigate to Device Info tab. We have them here. It's time to program ESP32 with Arduino IDE. Make sure you have installed the latest version of Arduino IDE. First of all, Blynk library must be installed in your Arduino. Navigate to Tools, Manage Libraries, search for Blynk. Install this library. You should see Install here. By clicking on it, installation begins. I have already installed this library. Then download the file in description and open it with Arduino IDE. This is the lines for configuring ESP32. Fill in information from Blynk device info here. Replace the lines you copied from Blynk with these 3 lines. Add the name of your Wi-Fi network here and add its password here. I use GPIO 16, 17, 18, 19 as outputs. Set a name for each of them. Relay 1 for GPIO 16, Relay 2 for GPIO 17, Relay 3 for GPIO 18, and Relay 4 for GPIO 19. As I want to trigger relays with buttons, I add 4 buttons. Button 1, button 2, button 3, button 4. I use GPIO 13, 27, 26, and 33 as inputs. These 4 lines initialize GPIO 16, 17, 18, and 19 as outputs, and these 4 lines initialize GPIO 13, 27, 26, 33 as inputs. In loop section, or let's say loop function, these lines specifies or let's say defines what happens if button 1 is pressed. It changes the status of the value of status 1, then the value of the status 1 will be replaced with value of relay 1 and value of virtual pin 0. We have similar lines for button 2, button 3, and button 4. In each of them, For example, for button 4, if the button is pressed, a status 4 value will be inverted and its value will be replaced by value of relay 4 and virtual pin 3. This function is called every time the virtual pin 0 state changes. And what it does is that it reads the value of virtual pin 0. If the value is 1, status 1 is set to 1, else status 1 is set to 0. And then value of relay 1 will be replaced by value of status 1. We have similar functions for virtual pin number 1. This function is called every time the virtual pin 1 state changes, and the rest of virtuals. For virtual pin 4 and virtual pin 5, we have different actions. Virtual pin 4, if it is set to 1, it means we want to trigger all relays. So set status 1, status 2, 3, 4 to 1. And whenever virtual pin 5 is set to 1, it means that we want to set all relays to off. Set status 1 to 0, status 2, status 3, and status 4 to 0. You can add more relays. What you have to do for doing so is that adding outputs and inputs in these sections. Then you have to copy these lines and paste it for each of the added relays and change the button's name, the status name, and relay name and virtual pin number. Also, you have to copy these lines and paste it again and add some names of it. For example, I copy these lines, paste it here. Pin number 6, virtual pin number 6. If its value is set to 1, change status number 6 to 1, else change its status to 0. If we have added button, we do it. Let's skip it. Okay. By adding the 5th button, you have to add this line to Blynk write v4 function. The status, for example 5, set it to 1. And you have add the same line in this function. But instead of setting it to 1, you have to set it to 0. I connect my development board to PC using USB cable. In Arduino, I select Tools. In Port section, I select the port my ESP32 is connected to it. And in Board section, I select my board. It's already done. Then I navigate to Sketch tab, select Upload. Uploading is done. Let's head to wiring our ESP32. Connecting keypad with 4 buttons to ESP development board. Connect the first pin to GPIO 13 of development board, which is done by blue wire. Connect second pin to GPIO 27 of development board, which is done by green wire. And yellow wire connects the third pin related to the third button to GPIO 26 of development board, and white wire connects pin number 4 of keypad to GPIO33 of development board. And the last pin must be connected to ground of development board, the black wire. Connecting relay module to ESP development board, DC plus must be connected to 3-volt pin of development board. DC minus must be connected to ground of development board, and input of relay module must be connected to output GPIOs. For example, for relay 1, it must be connected to GPIO 16. For relay 2, it must be connected to GPIO 17. For relay 3, it must be connected to GPIO 18. And for relay 4, it must be connected to GPIO 19. I connected this relay module to relay 1, GPIO 16. The input of relay module is connected to GPIO 16 of development board by brown wire. Black wire is connected to ground of development board, and the red wire is connected to GPIO 3-volt DC pin of development board. Also, I connected this relay module to relay 4, GPIO 19 of development board, which is done by orange wire. Let's set up Blynk app together to see how it works. Open Blynk app. As you see, we have a smart switch in devices section. Open it. Click, or let's say tap on wrench icon. Tap plus at the top right corner of the display to add widgets. Select button. Select the button by tap on it. Choose its data stream, switch 1. I want it to be as a switch, so I choose switch mode. I navigate to design tab, set a title for it, switch 1. Off label, on label, on. Again, I tap plus, choose button, select it, select data stream switch 2. I want it to act as switch, set a title for it, off and on label. Do the same for the rest of the buttons. Now I want to add all on and all off. I add button widget, choose its data stream. The mode I select push rather than switch. And for all off, again I want it as push button, all off. Setting up Blynk app is done. Let's test our project. Before testing our finished project, a smart switch, let's say that there was a change in wiring these two relay modules. This relay module works with 5-volt DC, so I connected DC plus to 5-volt pin of development board, and this one works with 3-volt DC, so I connected its DC plus to 3-volt DC pin of development board. Okay, we have a smart switch with ESP32 and Blynk platform. This button triggers relay 1, this relay module. The second button triggers this LED. and the third button triggers the second LED. As you see, we have the feedback of current status of each output in Blynk app, and using both keypad and the app, we can trigger outputs or set them to off. We have all on and all off. It's working flawlessly. Congratulations, you have now learned how to create a smart switch using Blynk and ESP32. By the way, in order to program ESP32 with Arduino IDE, an add-on must be installed. To find out more about it, watch its tutorial. I hope you have found this video helpful and you are inspired to create your own IoT projects with these powerful tools. If you have any questions or comments, feel free to leave them in comment section below. Also, if you are interested in learning more about Blynk and IoT development boards and how to create your own IoT devices, subscribe and press the bell button to receive every new video. In the next video, I will show you how to have a motion sensor in Blynk. Thank you for watching.